Assalamualaikum and a very good morning to Dr. Nuraini and fellow friends. We are from Group 19 and we will present about coating. Our group consists of me, Adriana Nabilah, Muhammad Nur Azwan, Ainul Mardiah, Nur Atira, Kiasatina Rawah and our leader Ong Teng Yi. Without further ado, I, Adriana Nabilah, will begin the introduction of our topic today. What is coating? Coating is a process that refers to a method used to apply a protective layer on a surface. According to Bose, the selection of a specific coating process depends on the design of the component and its intended application, such as protection against hard corrosion or oxidation. For example, we can think about the silver-plated spoons. They don't just look shiny, but they are also protected from rust. So, moving on, electroplating is one of the most common coating methods and it relies on an electrolytic cell. So, let's break this down. An electrolytic cell uses electricity to drive a non-spontaneous reaction, turning electrical energy into chemical energy. In electroplating, the object to be coated, like a spoon, is connected to the cathode, while the anode is made of the metal that you want to coat it with, like, for example, silver. So, when the current flows, silver ions from the electrolyte reduces at the cathode, forming a thin shiny layer on the spoon. Meanwhile, the anode dissolves to replenish the ions. Now, let's talk about the science behind it. Electroplating works because of the redox reaction, where oxidation and reduction occurs simultaneously. To pick the right metals, we can use the standard reduction potential, or known as SRP. For instance, the anode that is the negative terminal must be more reducing than the cathode. Next, the electrolyte must contain ions of the metal that you want to plate. Like, for example, we use silver, like the previous one. Here's one fun fact. Electroplating is not just about aesthetics. It also used in car parts, electronics, and even medical implants to make them more durable and functional. Imagine the phone that we are using right now doesn't have any shiny coating on its component. Our mobile phone or tablets may not last long. So to wrap up the introduction, electroplating is an amazing example of how electrochemistry helps us in real life. From protecting materials to making them look better, coating plays an important role in industries worldwide.
Now, let's move to the applications of coating. As we all know, coating can be applied in various fields of industry. One of example that I can bring to these discussions is automotive coating. Vehicles such as cars, motorcycles, airplanes, and ships undergo various types of coating for a lot of purposes. Today, I would like to put full focus on cars since most of us drive a car or become a passenger in a car to travel around. As you can see in this slide, I provided various examples of coatings that you can find on a car that I found from internet. Coatings on cars are applied for protections of the car body from environment such as UV light, rain, heat, and other weather factors that could disrupt the structure of the car body. At the same time, coatings on cars are applied for aesthetic purposes like car paints. So, this is one of the ways that car body can be coated. This process is called electrophoresis. This process is almost the same as electroplating, but it is different because electrophoresis coats with organic paint, while electroplating with metal or alloy. This process uses electric current to move dissolved paint particles to the opposite charged electrode in the cells, which are the car body. This process is known to be more eco-friendly than electroplating because it uses water-based coatings that create less waste. Hence, this type of coating can protect and give aesthetic value to the car body with less cost and less harm towards environment.
Galvanization. What is galvanization? Galvanization is the process of coating iron or steel with a protective layer of zinc to prevent rusting and corrosion. Zinc acts as a sacrificial metal, meaning it corrodes instead of the underlying steel, protecting it from rust. So, how electrogalvanization works? Zinc will apply using an electric current, depositing a thin, even layer of zinc onto the steel. So it is commonly used for smaller automotive parts and electronic components. The advantages of electrogalvanization is it can offers a smooth finish and precise control over coating thickness. Why is zinc important? Zinc important because it can protect iron and steel by corroding first, preventing the base metal from rusting even if the coating gets damaged. So, galvanization is essential for keeping iron and steel strong and rust-free, making it crucial for many industries where durability matters. Then, the gold plating. Gold plating is the deposition of thin gold layer on another metal. So, gold is corrosion resistant and highly conductive. Gold cyanide as electroplating solution. It has various classes such as alkaline cyanide, neutral cyanide, acid gold plating, non-cyanide, and mist. The example of gold plating is jewelry plating, electronics, and aerospace applications.
My name is Nur Atira and I will explain to you guys about importances and advantages of coating. First and foremost, coating can enhance corrosion resistance because most metals are prone to corrosion under harsh environment. By forming a protective layer of more resistant metal on the substrate surface, electroplating helps shield the vulnerable material from environmental factors. For instance, nickel plating is particularly effective in providing robust protection against moisture and chemicals. Next advantage is electrical and thermal conductivity can be increased. Coating highly conductive metals on electrical components, so electroplating ensures that the current flows smoothly and efficiently, enhancing the overall performance of electronic devices. Then, it increases performance of circuits where it will deposit highly conductive metals onto electrical wiring, or electronic components can greatly improve their conductivity, and it commonly applied in telecommunications, electronics, and aerospace. Moreover, the advantage is more cost effectiveness. Instead of the entire solid being expensive materials, only a thin layer of it is required to achieve the functionality. This allows customers the benefit of plating large scale of components, making more easier and cheaper maintenance. Besides that, coating by electroplating can also improve the appearance, which can alter the surface texture of metal parts. This advantage is most often used in the jewelry and automotive industries, where appearance matters. The last advantage is coating able to increase lubricity, which can be used to reduce friction of mechanical parts. It also reduces wear and maintenance costs, and really crucial in automotives in machinery.
As there are advantages in coating, there are challenges and concerns as well. Pollution is the main and most significant drawback of coating. Coating process generates various hazardous waste products which chemicals that are used are mostly toxic and can result to a polluted environment. The electricity production may cause environmental degradation such as greenhouse gas emission and climate change. However, this negative effect to the environment can be prevented with effective waste management, choosing the right raw materials, and making the most out of them by incorporating efficient processes. Coating industry workers which are exposed to organic solvents, resins, and pigments are the most likely to be exposed to the hazardous chemicals. Personal protection equipment is essential to protect ourselves from getting exposed to chemicals that can get into the body through inhalation and skin contact, such as respirator cartridge, goggles, and so on. If safety and protections are not taken into consideration, operators is at high risk in receiving several health issues such as asthma, throat irritation, and drowsiness. Next, in coding, there are limits in the usage of materials for different coding methods. In anodic oxidation and micro-oxidation method, only certain types of conductive metals can be used, such as aluminum, magnesium, and titanium alloys. There are many reasons as to why different materials are used for different methods, and some of them even require only the high grades of alloys. Other challenges to coding is that coding are expensive due to the high usage of voltage and temperature, which also requires a huge power consumption to meet necessary conditions. The cost of coding can also differ depending on the type and quality of the coding process. To achieve a more durable and long-lasting coating, nanotechnology that provides a stronger bond to the surface being coated are often used. However, these high-quality coatings tend to cost more. Failure in coating can also be costly.
Now we have arrived at a conclusion to summarize everything in this presentation. Coating, in this case done by electrochemistry, uses a setup of electrolytic cell. But that is not true for all coatings. See, coatings can involve electrochemical processes such as electrophoresis and not limited to electroplating. Logically, people use the electrochemical way to make coatings when they cannot use the spray painting method, like metal coatings. There is a specific method called metal spraying, but it is not always the best choice for all companies. Some examples of coating using electrochemistry are automotive manufacturing, gold plating, and galvanization. But there are more that we have not covered. The coatings have their own specific functions, but generally resist metal corrosion, improve conductivity performance, especially for electrical components, make productions more cost efficient, enhance appearance, and reduce friction wear. Therefore, you will get more durable metal parts. We have also discussed about how electrocoating can have downsides since it has its pros and cons. Challenges faced in electrocoating are potential environmental and health hazards, material limitations, and the high cost of setups. Coatings are particularly important in mass production industries. So people need to come up with ways to reduce the disadvantages of electrochemical coatings and to maximize efficiency, of course. Despite the challenges, industries should put effort in improving waste treatment, as most factories will do to prevent contamination. Using green energy as a power supply, this is also one of the SDGs to reduce carbon footprints. And last but not least, recycling and purifying waste metals. This is mainly for cost saving. It is all to make the electrochemical industry have less negative impacts towards the world. Here is the list of references we have read during the research of this project. Hope that you have learned useful knowledge from our video presentation. Thank you for listening.